Watch Mr. Wizard. That's what all the kids in the neighborhood call him, because he shows them the magic and mystery of science in everyday living.
Hi, Mr. Wizard.
Well, hi, Rita. Come on in.
Oh, it's rock candy, isn't it? We had
That's
that.
well. Now I like to think of it not as rock candy, but homemade diamonds.
Yes, it does shine
Doesn't
like
it?
diamonds.
Doesn't it shine
yes.
like diamonds? In fact, what, you buy rock candy like this?
Yes, we do.
Well, instead of buying rock candy like this, why don't you make it yourself?
Make it?
Sure. Very
Well,
simple.
how could I make it?
Well, I'll show you. I'll give you the instructions for how to make your own crystals of sugar, which is what they are. Because today you and I are going to investigate how to make your own sort of homemade jewels. Here's one, which I like to call a diamond.
Diamond?
Here's another one down here. You see this one?
Yes.
This happens to be another kind of crystal that you can make with materials that you find right around the house, no trouble at all. And here's one that perhaps you recognize. You see
That's a
that?
mothball, isn't
That's a mothball. But really what it is a bunch of compressed crystals, and with it you can have all kinds of fun making crystals grow right in front of your eyes.
Oh,
So today you and I are going to have, I hope, a lot of fun making crystals out of three things. Sugar, and that second one, which I didn't tell you about, was salt.
That's salt?
And the third
Salt
one,
crystal?
mothballs. Those three things. Now, before we begin, maybe we better make sure we understand what a crystal is. What is a crystal?
Well, that's a crystal. Anything that has a certain shape.
Pretty good. I have a certain shape. You have a certain shape. We're not crystals. What you had better say is a crystal is a solid that has a geometric or very regular shape. Even though it looks irregular, there are regular angles to the corners and the planes of the faces. That's what a crystal
All
is.
the same
All the-
sides.
Well, they're not the same size. They're different shapes and sizes, but they have a regular relationship to one another. Let's start from the very beginning now about how a crystal can be formed. And to do that, let's have some fun with these things over here. See those?
Yes, those are things that you make cars and
Yes.
model building.
Let us say that this represents a solid.
This is solid.
A solid of salt made up of sodium chloride. Sodium and chlorine.
So this is sodium.
And that's chlorine. This has a positive charge on it. This has a negative charge on it. And they're bound together by electrical forces. And that's what holds these two atoms together to form a molecule.
That's what keeps them together.
Right. But when you put them into solution, or when you put them, get them in certain ways so that you can break these two up like this, these forces are no longer strong enough to keep them together, and other forces will separate them. For example, if you put them into solution. So these two forces, these two atoms are now going about by themselves inside a liquid, let's say. However, and they're moving around because they're hot. Heat energy makes them fly around, plus electrical charges and whatnot. They move around all. If you can now somehow get them to slow down, somehow as these things move around and they slow down, pretty soon they're going to attract each other again. Like this.
Just attract each other.
Yeah, just attract each other because they're positive and negative electrical charges.
Oh, just like magnets.
Well, they have north and south poles, but this is not magnetic now, remember, it's electrical. So they would come back together again like this.
Yeah, keep them together.
Okay.
They wouldn't-
Well, now, if at the same time these molecules are moving around like this and getting together, these atoms are getting together to form molecules, what happens now if two of them come together like this as they begin to slow up and move around?
Well, they should.
Would they end up like
come-
that?
No.
Why
they
not?
wouldn't. Because these are two negative,
Yes.
and they're sending out.
They'd repel each other.
Repel
would
each
they?
other.
What
That's
would
right.
happen then?
Well, then they'd repel each other, and they wouldn't be together.
Okay, then they would probably repel each other until they got like this.
That's right.
Now
Then
they
they'll
would attract each other. And it's quite possible that these two would be the same distance as these two. In fact, I'll put a stick in there to do that. So you now see how the fact that things are made up of these electrical charges, and rather regular electrical charges, that as the solution begins to cool down and these molecules can take whatever form their electrical charges would naturally put them in, how they could form a nice regular thing like this.
That's something a box.
A little
or
box.
Square.
Well, now if another one comes along like this,
This is another.
this is another molecule like
molecules.
this, would it end up over here being attracted like that?
No.
Why not?
Because just like before, these black and black should be black and white.
Okay, so you
Because of
put where it would be.
Well, it should be like this.
Should be out like that, shouldn't it? Or it could be over here like this, too, couldn't
Yes,
it?
any place.
Yeah, it
over
also
here.
could be up here like that, couldn't it?
I guess so.
Oh, I like that way.
You like it out?
Yeah, because I have a plan.
Plan?
Yeah. Can you put that one on there now?
Sure.
No, the other way.
The other way.
That way. See, I have them all regular then. Now, when another one comes along here like this, is it going to go like this?
No.
Obviously not.
No.
It's going to go
This
like
way.
that. All right. So now you see, because of the electrical forces between the atoms and the molecules, it now begins to form a very regular figure. I'm going to put the last bond in there
Put that
too.
in there.
Now, what do these sticks represent?
The electrical charges.
The attraction between them because of their electrical charge. Is that right? And there, you see, we have a nice little cube.
Oh,
Now,
black and white. The tracks.
if more molecules and atoms were around like this, would they end up being attracted like that?
Nope.
Why not?
The other way.
Which way?
This way. There.
Or
Black and white.
like that.
Uh-huh.
So that these two would be attracting each other and these two. And you could put sticks in there. And now you could see how if I kept going, you could keep adding
You
and
have a
adding and
train
adding. You'd
of-
have a whole train of them.
Hmm.
And because now of the regularity of their electrical charges, you would now have a crystal form. You see, because at the same time while it's going that way, it could also go this way, couldn't it?
Oh, we're going all ways.
Because these things would match. Okay, do you get the idea?
Mm-hmm.
Now let's illustrate that in a different way.
Those are sugar cubes.
Sugar cube in a box top. If each one of these sugar cubes represents this big thing like this,
So this is this.
each one of these corners
That's
now
smaller.
is one of those atoms,
Mhm.
except smaller. That's right. And you can see now how they're floating around inside a liquid. They'd be moving like this.
If they were heated, right?
With heat. Now, as the liquid got cooled off and these were able to clump together, as we explained in the first place, this whole group would also begin to cool off, and watch what happens to them.
They're all getting in order.
One's still out of order. But you see now how, as these molecules group themselves together, the electrical charges of the little unit crystals, this is a little unit crystal, would now form other units of crystals, you see? You could have whole long lines of them.
Like the train of that
Right.
would be smaller.
Right,
And
so
same
this
idea.
is now how you can begin to form a crystal. And this is a very big crystal made up of many tiny little crystals. All because you are getting the molecules free to move around somehow, allowing them to come together because of their own electrical charges. And when those electrical charges are free to act, they form the crystal.
We have a crystal.
And each type of substance has its own peculiar kind of crystal because each substance has its own form of electrical charges.
Oh, because there's
So-
all different kinds.
So what you're trying to do now that you understand the background, you can understand how you're going to make crystals. What you're trying to do is to somehow get a bunch of molecules of a solid free to move around so they can clump together.
Move around
Right.
and then clump together so then you can...
One way to do this is
Just-
take the solid and heat it up just directly so that you change it from a solid to a gas.
And then they'll be free to move around.
Free to
like you
move
said.
around. And then as they cool off, they'll condense. In fact, watch. I told you one of the things we were going to use was mothballs. Let's assume that this is a mothball molecule.
It's a molecule.
Or, well, let's say it's a unit crystal at this
All
point, all right? If you heat it up, no, they've got to be molecules. You're not going to heat them up and they're going to fly through the air. If you heat them up, they don't sit around here. They fill up the whole container like this. Watch out now. Now, if they're gas going all over the
Yes.
place. Now, however, as the gas begins to cool off, it would condense on the top, probably. I'll pretend it's at the bottom. As the gas, see, they're flying up all over the place. As it begins to cool off, look what would happen.
Oh, they're all in line again.
You see how they're beginning to form lines here? This is now a beginning of a crystal, just like the sugar, you see? Only this time the shape is different because these are balls and not cubes.
Look at the balls. They go right into the slot.
Yeah.
One, each
See,
other.
One ball is not on top of one
That's
like that,
right.
is it? They fall into these little slots. So automatically, you now get a crystal form. Let's do that with mothballs.
With mothballs?
And here's how you,
Okay, let's try.
here's how you do it. Watch. You have mothballs at home?
Yes, we do.
All right.
Keep the moths away.
You get a piece of aluminum foil like this, and you want to form some kind of a dish in the center. Take a can cover or something, or a bottle top or something like this, so that you can push it down here and make a sort of little pan, like that, see?
We have a pan.
Pan.
Made out of aluminum
And
foil.
then you want to put a top on it like this. Now, I happen to use a beaker, but you can use an ordinary glass. It probably won't break on the stove, because what you're going to do is to take this pan that you formed, see, and put it up here on a stove, and turn it at low heat, very low heat, because what you're trying to do is to get the mothball to evaporate and change to a gas slowly.
Like done slowly.
Slowly. So now the mothball sitting there is going to melt, and gradually it's going to change to a gas, and will condense here on the cool
It'll
side.
be all over the place.
Yeah. Now, when the molecules are floating around in the air and they're free to take whatever form they're going to take the form of the crystal of this substance. And I've already done that. And here it is. Here's one mothball evaporated.
Boy, that's beautiful.
You see those beautiful crystals in there?
Looks like ice particles.
Yes.
You know, sticking
Well,
out
if
of
you look
the
at them
edge of
closely, some of them look like little Christmas trees.
Yes.
Yeah, and see how they shine and glisten? So that's what happens when you take a mothball.
Oh, I can smell it.
Yeah, can you smell it? Now, gradually, these molecules will jump off into the air, and these will evaporate. So you have to keep it under cover, you know, so it won't evaporate. But that's what happens when you allow the molecules of a mothball to form its own crystal. And it's very beautiful and quite easy to do.
Sure
Just
is.
be sure you don't get it too hot, because you want the molecules to just be hot enough to get into the air, but not so hot they keep, you know, flying all
So
around.
keep it at a low
See, at a low heat. Right. And be sure your mother's around, because that might smell up the whole house with mothballs, and make sure that she doesn't mind.
Oh.
Well, now that's one way to make crystals, and that's pretty easy, because the mothball will change into a gas easily. But now I think probably the way that you will have the most success at home is by putting a solid in a liquid. And let me get those balls over here and show you what happens this time. If you put mothballs into a solution, you're going to have two kinds of molecules, aren't you?
Solution is.
Right, the liquid and the solid. And then they'll be all mixed up together this way.
So here's solution.
This is now a solution. The steel balls are the water, or the liquid, the probably carbon tetrachloride, or non-inflammable cleaning fluid. And the white balls are the molecule of mothballs, and you see it doesn't form a crystal, does it?
No,
They're actually all moving around this way.
they're not in form.
See, they're not in form. But if you now slowly get rid of the water molecules, take them away slowly, now these crystals of mothballs are going to be free to get that form that we want them in. So you slowly take away the water molecules.
Oh, no.
When you do it at home, I'd suggest you do it with heat rather than a magnet. But my water molecules are magnetic, so you go ahead and get rid of the water molecules. So you want to just put them here in this can cover when you get them out.
Okay.
Now notice I'm going to continue to...
Instant evaporating water.
There. Now, you see, the minute you got rid of the water, you see what happened?
Oh, they're in form again.
Yeah. Now, remember, I'm sorry, carbon tetrachloride. The minute you got rid of the carbon tetrachloride, why, the molecules were able to form into a crystal. Let's actually do this now. Let's do that with some off. Sure. Come on over here. I'll show you. Because over here, I have some liquid. Inside here is carbon tetrachloride with mothballs dissolved in it. See that? They're just barely some left. But if I take the clear liquid now and put it down here in the middle of this dish, as the liquid evaporates, it should leave the solid behind, shouldn't it? Now watch
Yes.
right around there. See it already?
There it is. It's like a ridge of crystals.
Now, I'm going to blow on a little bit.
Gee, they sure come up fast.
Yes, don't they?
Mm.
That's because in carbon tetrachloride, it evaporates rather easily. And I want to warn you about carbon tetrachloride. It is a very dangerous liquid, because when it changes to a gas and you breathe it in, especially over long periods of time, it could be harmful. So I would suggest if you do this, well, it probably won't hurt us here, but I would suggest when you do this in a well-ventilated room, or better yet, outside. You can try some of the other non-inflammable cleaning fluids that are not carbon tetrachloride, other types that are under trade names. Some of them are not harmful, and they will also evaporate mothballs.
Will they come up fast?
And they will come up just as fast.
Oh.
Now, where's another mothball? Did I put some down below? Here. Because this time, you can also do just the opposite. Once you have crystals like this, or a complete mothball, you can take plain, pure carbon tet, or the non-inflammable cleaning fluid, and put it over the top, and begin to grow crystals right on top of the mothball itself.
On top of the mothball?
Right on top of the mothball, yeah.
You have a whole dish full of crystals.
Well, not only does it a whole dish get full of crystals, but hair grows on top of the mothball.
A hairy mothball.
Now watch. See the crystals beginning to form
Yes.
around the edge again? Because we have allowed the solid mothball, or naphthalene, to take its characteristic crystal form. And watch, pretty soon you'll see them growing right from the top of the mothball itself. Well, let's let that sit for a minute because it takes a little while to grow. Meanwhile, let's now go to some of the other kinds of everyday materials that you can use to make crystals. My favorite, my favorite, using this exact same system, but using water, and instead of a mothball, use sugar. That's the best one. That's sugar and water. You've made fudge, haven't you?
Yes, I love to bake.
In fact, you brought some over the other day. It was very sugary.
Oh, it is very sugary. Oof.
Well, I had you make sugary fudge because
I had 2 batches in the other one. Oh, so sugary.
And the reason I wanted you to make a sugary one is because you were doing exactly the same thing they were going to do now, except that the crystals you got were very small, and that's why the fudge tasted sugary. Here's what you do. Take ordinary sugar and make about the same ingredients that you do for fudge. Dissolve the sugar in a small amount of water. In cold water, it's probably better. You can heat it up slightly, but not too much, because what you're going to do then is put the sugar solution away. And here is a sugar solution that's been sitting for about a week.
Wow.
And you see, if you look down in here, you see all the little crystals that are forming all over the side? Watch, I'll turn it. You can see, that you'll see as I turn it, they glitter and sparkle. Each one of those little shiny places that you see is a sugar crystal that is formed on the side of the glass. Now, I'm going to see if I can take the top off and show you. I'll get a tweezer, just a minute. Here. I use one of these slides because I want to...
Wow, that's hard.
Because you have to keep breaking away the top, but I wanted to pull it out so that you could see. There. Don't you do this at home because you'll probably ruin some of the crystals, but I thought I'd get this out so that you can... Because on the underneath surface, right here, are all kinds of crystals formed. Now, there's a whole lump of them right there. Now, notice that you can't see them too well, because they're so smooth and shiny that even when you grow a good one, you can't see it too well. So what I'd suggest you do is, after you've grown them for a while, here's what you do. After you've got them dried off, you spray them with silver paint. And this now will look like this. Isn't that pretty?
Oh, that's beautiful.
Looks like a sort of modern city.
Too?
No, they won't evaporate particularly, but the point is that you can't see the planes on this. And you see how all the light bounces off, but you can't see it too easily. When you spray it, you can see all the little planes, and that's what it looks
cities,
like.
Little buildings.
Little buildings.
City.
So when you finish with your sugar crystal, if you're not going to eat it, spray it with a silver paint out of a spray can, and you'll have this sort of effect. It's very nice indeed.
If you eat it, you'll have
now, these will also form on the bottom down here. So if you're going to grow crystals like this, you'll have them top, bottom, all over the place. Now, excuse me, I want to get a towel.
Okay.
Hmm?
Sure, nice.
Aren't they nice?
Beautiful shape.
Well, now, if you grow them this way, you're going to get a great big clump. And that's not rock candy, is it? You don't get rock candy in clumps like that.
No,
you
I
get
them
them
in strings.
in strings. Well, something like this over here, for example?
Yes.
Like that. All right, well, let me show you how you can make rock candy at home then. The problem with this sugar solution, you see, is that the crystals are growing all over the place, from the side, the top, the bottom, as you saw. So instead of doing that, you start them like this, and when you get one little crystal down there, tie a string on that crystal and hang it in the middle of a glass like this of sugar solution. Put a cardboard cover over the top to keep it clean, and now, where are the molecules that are of sugar that are floating around in the solution? Where are they most likely to stop?
Oh, and I guess in the coolest place.
No,
so that they
not the coolest, not the coolest. They would, that's right, they would on the coolest, but in this particular case, even, let's say it's all the same temperature. Where are there the most, where are there molecules that attract sugar molecules? Other sugar molecules.
Yes, I guess so.
Well, you remember how the two children's toys came together over there? Okay. Well, in this case, you're going to have a crystal in the middle. It's called a seed crystal.
A seed crystal.
Seed crystal. And other sugar molecules are going to more likely to stop at that crystal than in any other place.
They'll all jump on that one.
So they'll all stop there. And if you keep growing and growing and growing, this one will get bigger and bigger. If other ones start along the bottom, reach into the long tweezers and get them out of there so they won't form. And that way
you want them there.
Yeah, that way you can grow a whole string just like that.
Open a candy store.
Yeah, you can open a candy store. So this one might take months and months to grow. But that's the same kind I had over there hanging up, twirling around, because when you twirl it like that, you see how it looks like a diamond?
Yes.
Yeah. Now, you can't see the planes on this one particularly well, So what you do is you spray this. See that?
Yes.
Here is the same one, same sort of one, not the same one, but the same sort, but sprayed with the silver paint so that you can see the planes of the surfaces, yeah, aren't they? So they're very nice. Now, this will not happen overnight.
No? How
No.
long?
Well, to grow crystals as big as this may take months.
Months?
Yes,
Oh,
months.
I can wait.
Yes. To grow this kind over here, however, you can go much faster because you have many more places for the crystals to grow.
It's all over, but this one,
So this
one
you might be able to do in a couple of weeks or a month, depending on how saturated the solution was to start with. So anyway, that's the easiest one, and I'd suggest that perhaps you get some books from the library. I happen to have written a book myself that has a chapter in it in which there are some information about crystals, so you could use that one called Mr. Wizard's Experiments for Young Scientists.
So
But,
I have that, too.
well, then there's a chapter right in there, and you can look at that one. But there are many good books in the library that have whole chapters or whole books on how to grow crystals, so you might check. Because some of the things that you will use are not common ones. You can get some stuff from the drugstore and grow some things there, very beautiful crystals. However, to start with sugar. That's easiest. Here's the next one that's a little more difficult to grow. This is salt. And you do exactly the same thing. Get a saturated solution of salt, put as much salt in water as will dissolve, and then start with a seed crystal and let it grow. And here's what you get. Here's what it looks like. And notice how square it is?
Yes, it's very square.
Very
Over there, it's
much
long
different
and
shape.
boxes.
Well, now this is because salt is made up of little, well, I won't tell you. I'm going to show you some later on the microscope, and you'll see why.
On a microscope?
Yeah, we're going to look at a microscope, a new setup I've got, so that you'll see what this really looks like. In order to see it better, however, I have sprayed one down here, see it?
Yes, you can see it much better.
Yes. Now, this is not quite a square, but it is made up of little tiny crystals. This is a whole great big crystal. So try this one of salt. This grows very slowly, and you'll have to wait for a little longer time.
I think you can just make it with salt, and I thought you needed all the scientific
No,
chemicals
not
and-
really. The fastest one of all, however, is this carbon tetrachloride. Look at it over here.
It's on the mothball already.
See how it's beginning to grow in the mothball? Well, I won't put any more on, but see all around the edge how fuzzy it's getting?
Almost looks like a snow crystal.
Yeah, that's
Well,
right,
like
very
it's a
similar to
crystal.
it. If you keep going like this and keep adding more of the non-inflammable cleaning fluid, eventually you'll grow a mothball that'll stand about this high and have frost like this growing all over it. And later on I'll show you what this looks like under the microscope too. Anyway, that's the fastest one to grow of all, is carbon tetrachloride mothballs. But be careful with that carbon tetrachloride, it's very dangerous. Well, now that salt crystal that we had over there, let's look at what a single salt crystal looks like when it comes right out of the salt shaker. Here, come on, sit down. Here is a new microscope set up. Before, remember we had a little screen up here and we had a difficult time seeing it. So this time, instead, here's a microscope with a light down below, and we can put slides here. We project the light up through here, up to a little television camera.
Oh,
See?
so you got your own little camera.
Own little
around here.
camera. So here's the little camera, the cord goes down over here, and it comes over here on that screen. So that we can both see the same thing by just simply looking over there at the screen.
Oh,
So
very
let's
nice.
set up a slide. Here is a slide, and here's some salt. One salty slide. I'll put it under the microscope, and now let's look at it at low magnification.
There they are. Like
There
little
they are.
boxes. Aren't they squares?
Little squares, that's right. Now, what you're really looking at, of course, is a three-dimensional figure. And a three-dimensional square is what?
A cube.
It's
It's
a
like
cube.
a cube of sugar.
That's right. These, just like the sugar cubes that we saw over there, yes. What we're looking at here, however, is magnified about 100 times. So that looks like a small, that is a very, very small. In fact, you'd have to divide that by 100. One edge would have to be divided by 100 to get its correct size. Now, there they are magnified 100 times. Let's magnify them now 350 times to get an idea of what a salt crystal really is like.
Look how big they are.
Anyway, there's
Big.
now, notice that the salt crystal, as it comes out of the salt shaker, is a little cube. And each edge of that cube is now made up of trillions and trillions and trillions of molecules.
Trillions?
Yes, trillions.
Of all the salt we use on
And how many
food.
molecules there must be to make one of
Yeah.
these little tiny cubes. And what you saw on that big crystal I had over there were many of these kind of crystals put together, because they all
All
formed one
together.
after the other. That's right. Well, that's what salt looks like under the microscope, a real crystal. Now, remember, I also said that the easiest crystal to grow was carbon tetrachloride?
Yes.
Well,
It goes very fast.
it goes very fast. I'll put a slide under here, under the microscope. This is a slide that has a little well in the middle, a little hole, a little dent. And in that little dent, I'm going to take a saturated solution of mothballs in carbon tetrachloride.
So that's what's in there?
Yeah. Remember I
so
put it
over there,
put
over
it in
the
that little
mothball.
dish? Or I put it there in the little dish and it began to grow. I'll do that same thing now here under the microscope. Oh, wait, I'm sorry. I want to go to a little magnification first so we can... There, I put a drop of liquid there. And now I will move this slide around until I get to one of the edges. And you remember how we saw that edge growing over there? Well, there it is forming right in front of your eyes. Look at that.
Gee, I never saw that before.
This is now crystals forming right. And the reason you see different colors here is this is polarized. So when the crystals are turned in certain ways, you see different colors.
Oh, it's so beautiful.
Now there, remember, each one of those lines that you see there is composed of trillions and trillions of molecules. Now as it begins to dry up, I will put another drop of that saturated solution on there, and I will evaporate the crystal that has just formed. Watch.
There goes the drop.
See how they're now evaporating? In other words, the molecules of the naphthalene can now are free to fall one over the top of the other. They're no longer held together in this crystal form. But as soon as that liquid begins to evaporate, why, they're going to be free to come back together again. So watch. They're going to start forming now. See them coming in?
Yes. There they come. They just pop up.
Well, sure, that's because they
Like a flower.
suddenly these molecules begin to come right together to form this crystal as the liquid evaporates. Okay, well, let's take another look at this again, but before we do that, I want to make sure that you understand about crystals. Would you go over and get that box full of balls over there while I put a
The
new
white
slide
balls?
on? Yeah, the white ball with the box, and the top. Okay.
Ooh. There.
Now, if you want to make crystals at home, let's take mothballs, because they're the ones that work the fast, and then you can do the same thing with salt and sugar. One of the ways to make a crystal is to take the solid and change it to a gas, right? And when the gas settles down and is free to form, it will form into a crystal because of the electrical nature, the electrical forces between the various kinds of molecules. So that's one way of making it. The other way would be to take a solid and get it into liquid form. Sometimes with sugar and water. And when you evaporate the water, eventually the solid will settle down and form a crystal again, right? So those are the two ways. And the fastest way of all, of course, is carbon tetrachloride. And you can see the crystal growing right in front of your eyes like this. Watch.